This is a 2014 Bc Frq, number 2. So we have two curves, excuse me. This one is just a circle with radius 3, so it's r equals 3. This one is 3 minus 2 sine 2 theta. And part A is asking the area of the shaded region. There's two ways you can do this, so let me show you. I will do it up in the top corner here. So areas in radians are formed by going through angles. So we start with 0 right there. So that's theta equals 0. Now if I keep on rotating this angle, you will see this continues until we get to pi over 2 there. So the function changes at that point. So let me show you that. This here, wow, that's pretty bad. This here is 1r, and this is the other one, just the half a circle. So as you can see at this point, we're no longer following the blue curve, but we're following the fuchsia one. And so it's going to be a separate area formula. So for the first section, the area is 1/2 the integral from 0 to pi over 2, and it's r squared d theta. And to make my life easier, I would like to say this. Let r1 equal 3 minus 2 sine 2 theta. Therefore, when I write that, I don't have to write the whole thing out anymore. I'm just going to do r1 squared d theta. So that's the area of the golden section. And from that point, things change. So from here, which is pi over 2, as I map out this region, going through angles, it stops at pi. So I can do calculus and say, you know what, that's 1/2 the integral from pi over 2 to pi of the red curve, which is 3 d theta. So I can put that in the calculator, and if I do that, I would get this, 9.708 if you round off, or if you truncate, 9.707. So that's just calculator work. Now, a note, this is just a quarter circle. So you could have did pi r squared over 4. Since the radius is 3, it would have been 9 pi over 4. So you could have done that and just use formulas for areas, or you can do the calculus, whichever way you prefer. Okay, we're on part B. We want dx d theta. So you have to convert your r into an x form. So you should know x is r cos theta. And I've defined r1 over here, so I could just write r1 cos theta. Since this is a calculator problem, once I define x, I can say dx d theta at theta equals pi over 6. Pop that in the calculator to get your answer, and it comes out to be negative 2.366. So that's the answer to B. So your calculator is allowed to do the derivative, but you must state what x equals. Because if you don't do that, then you're not really explaining how you took dx d theta. But once you find x, then you're allowed to put that in your calculator. So part C, the distance between the two curves changes between 0 and pi over 2. Find the rate at which the distance between the curves is changing with respect to theta when theta is pi over 3. So let me erase some stuff here. Let me undo that. So pi over 3 is somewhere around there. So what is the distance between these two curves? If you look at this, it's this distance. And that's going to be the pink r minus the blue r. The pink r minus the blue r. So for part C, I could call it D, I guess. That's what the study guide says, or the scoring guidelines. So distance is big R, which is 3, minus little r, which is R1, which I defined up here as R1. You could write that whole function out if you wish. So they want the rate at which the distance between the two curves is changing at pi over 3. So they want the derivative with respect to theta at theta is pi over 3. And again, this is a calculator problem. You put this in your calculator, you take the derivative of pi over 3, and you get an answer for that of -2. So that's the answer for part C. Pretty straightforward. Now we have part D. I want to create some space for me, so let me put a white box here and get rid of those lines. There we go. Part D. A particle is moving along the curve. So it's moving along the blue curve. And they're telling us that d theta dt is 3. So you have a particle moving along this curve, and the angle's changing. So it's sweeping as the angle changes. And they say theta changes with respect to time at the rate 3. So 3 radians per unit of time. So that's given. Then they're asking for dr dt. So they want dr dt. So for part D, they want dr dt. I need a differential equation with r in it, but I have this given. So I can find dr d theta. I know how to do that. And that will be -2 cosine of box times derivative of box. So when you take the derivative of this is chain rule. The derivative of 3 is 0. -2 gets copied. The derivative of sine box is cosine box times derivative of box. So I end up with -4 cosine of 2 theta. So that's what I get for dr d theta. Now this is a chain rule situation. I want a dr. There's a dr. So I'm able to find dr d theta. Now I want a dt on the bottom. But look, I'm given a dt statement. I know I can get, sorry. I have a dt right there. That was what I'm looking for. But there's a dt right there. So I know I can deal with the d theta dt. And if you look, the chain rule works nicely, and I get that. So this is what's going on. And you could have written this all at the first time. When theta is pi over 3 equals dr d theta when theta is pi over 3 times d theta dt when theta is pi over 3. Well, we know a couple of things. We know d theta dt is 3, always. So I can replace that with a 3. What's dr d theta at pi over 3? I have dr d theta here, right? So at pi over 3, we would put pi over 3 right there. So that would be -4 cosine at 2 times pi over 3. Now you can do that in your calculator because this is a calculator problem. But cosine of 2 pi over 3 is going to be -1/2. So I look like, to me, what is that, -6? And there is part D, and I am done.